Hello everyone, this is Group 4 and our research is focused on the factors affecting a developer's job satisfaction and their yearly compensation. The dataset we will be using for this survey is the 2023 version of the annual Stack Overflow survey for software and data engineers. Our group includes me, Keon, Shaila, and Tina. As most of us will eventually go and work in the tech industry, we thought it would be interesting to see how people in the industry feel about their job, as this would give us an insight into whether life will become better after graduating from MITS or will we still be miserable. Now, Keon will take it from here.
For 13 years, Stack Overflow delivers industry-leading insights regarding the developer community and to understand where tech might be going next. This year's survey was between May 8th to May 19th, with 91,000 software engineers from 185 countries. 7 primary sections covered in the questionnaire were basic information, education, work and career, technology and tech culture, Stack Overflow usage, artificial intelligence, and professional developer insights. We decided to answer 2 main questions. How much will the developer earn based on their answers in the survey, and what factors contribute to a developer being satisfied at their job? We visualized our outcome and realized there was a riskiness of the converted yearly salary after excluding outliers. The majority of respondents indicated salaries between 50 to 150,000. The distribution of remote work across different levels of work experience and compensation is well balanced between hybrid, in-person, and remote, but does not significantly influence an individual's earning. Our aim was to also investigate the interplay between job satisfaction, compensation, and age. We observed a consistent trend where higher salaries correlated with greater overall satisfaction. As anticipated, the data revealed that on average, as individuals age, their median salary tends to rise, aligning with an increased likelihood of job satisfaction. Finally, job satisfaction tends to follow a near normal distribution, with bulk of the observation falling within the standard deviation of the mean. We categorize job satisfaction into 3 groups based on the quantiles: not satisfied, neutral, and satisfied. Tina would explain our research methods.
For our first research question, we built a multiple linear regression model to forecast a developer's annual compensation. The predicted variable includes age, type of work, years of coding experience, education level, years of working experience, and number of programming languages. We also include an interaction term with educational level and years of coding experience. During the model fitting process, we checked multicollinearity and model regression assumptions. We also excluded influential points. In the end, we applied cross-validation to different models and used ARM-SE and R-square to assess the accuracy of the prediction model. The VIF of the preliminary mean regression shows that the variables are not correlated with each other. Our final regression model has log-transformed yearly compensation as an outcome variable with an interaction term between education level and years of coding experience. This model is based on an updated dataset with influential points excluded for more accurate results. We developed 2 models for comparison: the main model, which includes an interaction term, and a secondary model without this interaction term. To evaluate the performance of these models, we use ARM-SE as our primary metric. Through cross-validation, we found that the ARM-SE of the main model was approximately 1.097, lower than the secondary model's ARM-SE of 1.099. The main model is a better model with predictions more closely aligned with actual outcomes. A low R-square value of 0.14 indicates that the model explains only a small portion of the variability in the response variable. However, in our case of dealing with human factors and complex systems influencing salaries, a lower R-square might still be considered acceptable due to the inherent variability in the data. Now we are interested in predicting Faraz's salary after his graduation of MITS program using our model. Faraz, at 26 years old after graduation, is proficient in 6 programming languages, has gained experience in a hybrid work setting, and possesses 1 year of general work experience along with 2 years of professional coding experience. Additionally, he holds the MITS master degree. Based on these factors, our model forecasts Faraz's annual compensation to be approximately 50,000 USD. Now, Shaila is going to present the second research model.
Let's now dive into our second research question, focus on understanding the factors that influence job satisfaction. For this question, we employ ordinal regression to explore the elements shaping a developer's job satisfaction on an ordinal scale with 3 categories: satisfied, neutral, and dissatisfied. We consider different key factors that we think might influence job satisfaction, such as age, type of work, yearly compensation, the incorporation of artificial intelligence in the job of the person, an organization size. But we also created an interaction term to investigate if our age group changes our perceptions between different generations, taking into account our salary. To test proportional odds assumption in our model, we conducted a comparison between the predicted probabilities between the multinomial model and the ordinal model. We can see on this table that the predicted probabilities for the neutral category, that is our biggest group, are very similar for both models. And we can also conclude that we do not have a strong evidence that the proportional odd assumption is violated. Most of the variables we selected, sadly, were not significant, except for one, organization size. Specifically for organization with the smallest group of employees, ranging for 2 to 9 people, the odds of experiencing higher satisfaction in the job increased significantly. Workers within these small companies have odds that are 2.35 times higher for higher job satisfaction compared to those in larger organizations. Moreover, our analysis show a trend. As the size of the organization increases, the likelihood of predicting job dissatisfaction also increases. These findings suggest an inverse relationship between organization size and job satisfaction level.
So the wide variety of categorical and numerical variables chosen for the model during priori selection, along with an interaction term, adds a lot of depth to the model and helps understand what factors jointly and on their own affect yearly compensation. However, we could have improved on the model's predictive capability and its precision based on a few changes in the variables. For example, changing age to a numeric value rather than a category spanning over several years, during which an individual's salary can drastically change. Our R-squared value was also very low, suggesting that the relationship between our variables might be non-linear, and a simple linear model might not fully capture it. For future, we can maybe improve our model by exploring other complex models, such as polynomial regression, and also by converting non-numeric data to reduce bias and improve precision. For our other research question, we realized that the relationship between our predictor and outcome variables lacked some explainability, which made it hard for us to evaluate our model. For future work, we can explore other factors affecting job satisfaction by collecting data from other diverse sources. Thank you.